Welcome to my channel, dear students. So today we'll continue our series of integration using substitution. Now in this particular video you'll see the usage of 6 important standard integrals which are being shown in the screen right now. Okay, so I request you to pause the video and note down the formula, that is 6 important integrals. Okay, now let's have a look at the first question. So number 1 says we need to prove this integral equals to this much. Okay, so let me call this to be I as usual. Okay, so let I equals to, so we can write this as dx by, okay, now if I try to convert this in one of the 6 integrals which I showed just before this, then this can be converted into x square minus a square, that is a square can be written as 4 square, right? And we know that the formula for integral dx whole divided by x square minus a square is equals to how much? It is 1 by 2a, and how much is a? A is 4, right? So it is log x minus a is how much? A is 4 here. So a whole divided by x plus a, and how much is a again? A is again 4, right? Okay, so since this is indefinite integrals, we don't have limits given, so we have to put constant of integration after the integration is done. So how much is this? This is 1 by 8 plus, so it is 1 by 8 log x minus 4 whole divided by x plus 4 with constant of integration. So that's what we were supposed to verify out here. Okay, so this was our first question. Now let us go to the second question. So again, this is my I. Okay, so we have, now this can be written as 5 square minus, this also can be written as something whole square, right? Okay, so I is equals to, we have integral dx by square root of, so as I said, this can be written as 5 square minus, this can be written as 2x squared, right? Okay, now if you see in the formula, this is matching to this one, that is integral dx by square root of, first is constant, so a square minus x square, it is matching to that. But here if you see, we have got x square, that means the coefficient of x square is here how much? It is 1, right? So let's try to convert this into only variable. Okay, so that means I'm not going to keep only any constant with the variable, right? So here the variable is 2x, so that's why I'm trying to keep it only as x here. So let me convert this 2x into, okay, so let me write, let 2x is equals to t. Okay, so if I do that, then from here we have 2 dx equals to dt, that is dx can be written as half of dt, right? Okay, so therefore this I can be written as integral dx can be written as half dt, so half can be kept outside, so we have only dt left out here, right? So it is square root of 5 square minus 2x is how much? 2x is t, so t square. Okay, and how much is this? Now this is going to be equals to, according to the standard formula, is going to be how much? It's going to be sine inverse x by a, and how much is x? X is t, and what is a? A is 5, right? And replacing the value of t, so we have half sine inverse of how much is t? T is equals to 2x, so 2x by 5. So that's what we need to show, but we need to put constant of integration as well. Okay, so you may pause the video to note down. Now let us move on to the third question. So question says that integral of this will be equals to this much. Let's see how. So here again, let's try to substitute something, right? Because it's not given in the standard form, so let's try to do some substitution here. For example, I can write this as, okay, so let me write this as I So we can have I equals to, so integral e to the power x dx. So let me write this as e to the power x whole square, right? So this can be done, and this 4 can be written as 2 square. Okay, now as usual I am going to do substitution, and let me do the substitution to be, let e to the power x equals to t. Okay, so if I do that, then what is the differentiation of e to the power x? It is e to the power x dx will be equals to dt. Okay, so that means this can be written as dt. So we have I equals to, instead of this I am writing dt, so dt by e to the power x is how much? T. So t square is there plus 2 square, right? And how much is this? This will be equals to 1 by a. A is how much? This, right? 1 by a tan inverse, how much? It is x by a. And how much is x? X is t. And how much is a? A is 2 with constant of integration. Now let me resubstitute the value of t, that is half tan inverse. And how much is t? T is equals to e to the power x by 2 with constant of integration. So that's what we need to verify out here. Now let us move on to this fourth question. So fourth question is, this I will be equals to this much. Okay, so again let's substitute in the very same way out here as well. Okay, so this I can be written as, integral of sine 2x by square root of 9 can be written as 3 square minus, and this sine to the power 4 can be written as sine square x whole square, right? So let me do one substitution here, that is this has to be written in standard form. Okay, so we already have a square minus this has to be x square. Okay, so let me write this to be, that is let sine square x equals to t. Okay, let us differentiate now. So when we differentiate, first let us differentiate square, so this becomes x square. So differentiation of x square will be 2x, and how much is x? X is sine x. Okay, now according to chain rule we need to differentiate sine x also, so differentiation of sine x will be cos x. Okay, and we will write dx as well, so this will be equals to dt. Okay, and how much is this? This is actually sine 2x cos 2x is, so 2 sine x cos x is sine 2x, right? So sine 2x dx can be written as dt, right? So let us go back to our formal question, that is I equals to, okay, so sine 2x dx can be written as dt by, we have 3 square minus sine square can be written as t square, right? So we have integral of dt by square root of a square minus t square form. Okay, and this is equals to how much? This will be equals to sine inverse x by a. X is t, right? And how much is a? A is 3. Okay, so we'll put constant of integration out here. Now let us resubstitute the value of t, and how much is t? T is equals to sine square x, so this can be written as sine inverse. Okay, so this 1 by t I'll write it separately. Okay, and now how much is t? T is equals to how much? T is equals to sine square x. Fine. So with this we come to the final answer. You may pause the video to note down. Now let us move on to the next question. So again, if I want to reduce this into standard form, I need to have, see, this can be written as a square. Okay, this can be written as a square because this is the constant term, and the variable term here is 2x plus 3 whole square. Okay, but as I said earlier, this has to be x square, right? That means there should not be any constant attached to x square, or in other words I should say that the quotient of x square should be 1. Okay, so to make this in the standard form, what we are going to do is we will substitute 2x plus 3 with t, so that it can be written as t square minus a square. Is that clear? Okay, so let me write. Okay, so this is my I. So let 2x plus 3 equals to t. Okay, the next step is we will differentiate. So it will be 2 dx equals to dt. So that is dx will be equals to half dt. Is that clear? Okay, let's come back to our work. That is I equals to, now dx can be written as half dt. So let me write this half outside. So we have dt by, this is how much? This is square root of, this square is how much? This is t square, and this 5 can be written as square root of 5 whole square. Yes or no? Now if I compare this with the standard form, this is my x and root 5 will be my a. Okay, and we know that the formula for this is equals to how much it is. Okay, so we will write first half. Okay, and formula for this integral will be equals to log, right, log x, and how much is x? X is t plus square root of t square minus a square, and how much is a square? This is root 5 square. Is that clear? Okay, with constant of integration. Now let us resubstitute the value of t. So half log, how much is t? T is equals to 2x plus 3 plus t is again 2x plus 3, and since there is square, so square, minus root 5 square, and how much is root 5 square? It is 5, right? So this gives me my final answer for this particular question. So you may pause the video to note down. Now you people are quite familiar with the change of particular integral into the standard form. Okay, so let us apply the same technique in our definite integrals, right? Okay, so let me call this to be I. Fine. So let me write it again. So I is equals to, okay, so integral of this, so we have got 4, so let me write this 4 outside. So we have 2 to 5 dx by, now this 1 can be written as 1 square minus x square, right? So basically a here is how much? A is 1, and we know that the formula for this will be 4. First let me write the value of the integral. So the value of the integral is going to be 1 by 2 a is how much? 1, right? So it is log a plus x, that is 1 plus x divided by 1 minus x. Okay, so this is the integral, and since we are doing definite integral, we need not put any constant of integration. Instead we will put the upper limit and lower limit values. Okay, so how much is this? This is equals to half, so this half can be taken outside. So let me write 1 by 2 outside. So let me put the value of limits now. So we have log 1 plus x. So first we have to put upper limit, that is 1 plus 5 divided by 1 minus 5. Okay, minus we have log, how much is this? This is 1 plus 2. If I put lower limit, so 1 minus 2. Let's simplify further. So this and this gets cancelled. So we have 2. So we have log, how much is this? This is 6 by minus 4, right? Minus, and how much is this? This is log of 3 minus 1. Okay, now this is log a minus log b, and we know that log a minus log b can be written as how much? It can be written as log a by b, and how much is a? This is my, this whole thing is my a, and this fraction is my b. So a by b can be written as, so a, that is 6 by minus 4 divided by, can be written as into, and this will be inverted itself. Okay, so minus 1 by 3. Is that clear? Okay, with okay, so this time I'm not putting any constant of integration, so minus and minus can be removed. So 3 1s are 3, 3 2s are 6, 2 1s are 2, 2 2s are 4. So this will be equals to how much? 2 log 1 by 2. Okay, so this will be my final answer. So you may pause the video to note down. Now let us move on to the last question. So we have I equals to integral 0 to pi by 4 x square dx by x square plus 1. Let us do some manipulation out here. So the manipulation that I am going to do here is 0 to pi by 4. I am writing x square plus 1 minus 1 in the numerator, which is allowed here, right? So let me write it this way. So pi by 4. So this can be written as x square plus 1 by x square plus 1 dx minus, okay, so we have this minus is kept here, so 1 dx is dx by 1 x square plus 1. Is that clear? So this and this gets cancelled. So here we have only dx left. So integral of dx will be how much? It will be only x, right? We know that integral of dx is x. So x is written. So we have 0 to pi by 4 minus, we have dx by, actually it is dx by 1 plus x square, and we know that this is equals to tan inverse x, right? So we have tan inverse x, and how much is x? X is x itself, right? Okay, so we have 0 to pi by 4. Now let us put the value of lower limit and upper limit. So first let us put upper limit, that is pi by 4, minus the lower limit, that is 0, minus tan inverse x, the upper limit, that is pi by 4, minus tan inverse lower limit, that is 0. Okay, now we know that this tan inverse 0 is 0. Okay, so we have pi by 4 minus 0 is pi by 4 itself, minus is there. So we have tan inverse pi by 4. So this will be my final answer. So pause the video to note down. Thank you very much. The sums that you are going to practice will be given in the description.